Hey everyone, I'm Haley if we haven't met already, and I decided to create a visual model of a human eye and tell you more about how the eye works. First, I'll teach you about the functions of the eye and then walk you through my model. So get ready for a lot of information. Every sight, color, and flash of movement around you starts as an external stimulus. For our eyes, that stimulus is light. We only perceive a tiny sliver called visible light, and this radiation travels through space, bounces off objects, and heads straight for our eyes. To turn this light into a clear picture, the eye must focus it. This brings us to the lens and a dynamic process called accommodation. Now, accommodation is the lens shape change required to focus light precisely onto the back of the eye. When you look at a distant mountain, tiny internal muscles relax, flattening the lens. And when you snap your focus to a book in your hands, those muscles contract, causing the lens to bulge and become rounder. This bending bends the light rays perfectly so that they don't blur. And the light lands on the retina, our biological projection screen. Here, light energy is converted into electrical signals by two types of photoreceptors, rods and cones. Their distribution and the visual input they detect are completely different. Cones are tightly packed right in the center of your retina, in an area called the fovea. They detect fine detail and vibrant color, but they need bright light to work. Now, rods dominate your peripheral vision. They cannot see color, but they are incredibly sensitive to light and motion, allowing you to navigate in near total darkness. And once the rods and cones fire, the raw data begins its journey along the visual pathway to the brain. The signals travel down the optic nerves until they meet at the optic chiasm. Chiasm? Sorry if I'm saying that wrong. Here the paths split and cross over, sorting the information so that the left hemisphere processes the right half of your world and the right hemisphere processes the left. The sorted signals pass through a relay station in the brain and make their final stop at the primary visual cortex, located at the very back of your head. It is here in the dark chambers of your skull that the electrical impulses are finally decoded into images, shapes, and colors. In less than the blink of an eye, a wave of electromagnetic radiation becomes the conscious experience of sight. So now I'm going to walk you through this little diagram that I made. So first you have the optic nerve right here, and that takes electrical signals to the brain. And notice that the retina's blood supply comes in through the center of the optic nerve. And then you have the fovea right here, and that is the focal point, the center of your vision. And then right around this area is called the macula. And then number 4, all back here, is called the retina. And that's the back of the inside of the eyeball. And this is where the light-sensitive rods and cones are located. And then you have the ciliary body, and that is number 5 right back here. And I colored it wrong. It's supposed to be more like muscle colored because it holds the lens in place and has tiny muscles that can change the shape of the lens. And then you have the lens right here, this little clear right there. And that focuses incoming light onto the fovea back here. And then number 7, you have the iris. That is the colored part of your eye, and it adjusts the size of the pupil. And then you have the cornea, and that's this clear protective layer. And then the sclera, number 9 up here, is the white outer layer. And then 10, we have muscles, muscle on top, bottom, and sides that allow us to move our eyes in all directions. And then you have the lacrimal gland up here that makes tears. And the vitreous humor is number 12. So like all of this is a clear gel that fills the inside of the eye. And then the choroid is the layer inside the sclera. The retina lies on top of the choroid, right back here. So I hope you enjoyed, and I appreciate you watching. I've already taken plenty of your time. So thank you so much, and I hope you have a great rest of your day.